Falling is the foremost cause of injury and mortality for elderly, causing millions of deaths and billions of dollars on medical costs per year in the United States. Freezing a gait, an episodic freezing pattern, encompasses 30% of all falls and is caused by a variety of neurological and ocular dysfunctions. Current solutions in place are highly ineffective, such as grip socks or weakened brain muscle activations, such as wheelchairs. I have recently taken a dive into electronic systems and I decided to use my new knowledge in this application. Hello, I'm Krishna Bhatt from grade 8 with my project The Balancerator, a novel wearable for active prevention of falls through gyroscopic inference and center of mass manipulation.
The human center of mass is around the navel area, making the weights having to be at around the same height. As proof of ideology, I made a simulation of this concept. I also found that adjusting weight distribution does not affect the anticipatory postural adjustments in any way. The gyroscope that I used had large amounts of ARW and bias instability, so I had to use Kalman filters to reduce noise. I first used the gyroscope's Allen deviation plotter to determine the quality of the noise as wide Gaussian. I then used Kalman filters to exact down the measurement values by finding the weighted average of the predicted curve through convolution and the raw measurement curve through Bayes' law. The gyroscope's angular velocity measurements were converted into angles through Euler integration. The project utilizes an Arduino Uno along with 5-pound weights attached to shafts. The cross shafts and the belt construct is designed to reduce load. I also designed an application with BLE communication to provide live reading, statistical insights, and emergency contact capabilities. In the end, my Kalman filtration reduced gyro bias by 93%, and the device had a 71% lower fall rate than the control with over 500 data points tested. The motors took an average of 1.5 seconds to turn, which is acceptable considering the applications of this device. Here's a video of my testing, and you can see that the weights move back and forth as a scale of body inclination.
The project has the capability to significantly reduce falling rates and instill confidence in both the patients and the families.